Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us begin solving this step by step. 1. Indenone is a 5-membered ketone fused to a benzene ring, cyclopentanone ring fused to benzene. Moving on to the next step. HCN adds to the carbonyl of 1-indenone via nucleophilic addition to give a cyanohydrin. The CN group adds to the carbonyl carbon, C1 of the cyclopentanone, and OH is also on C1. This converts the 5-membered ring ketone into a 5-membered ring bearing both OH and CN at C1, effectively inserting one carbon, as CN, at the carbonyl position. The cyanohydrin has the structure, benzene fused to cyclopentane ring with C1 bearing OH and CN. Moving on to the next step. Lyl4 is a strong reducing agent that reduces both the nitrile, CN, to a primary amine, CH2NH2, and also reduces the OH-bearing carbon. Actually, Lyl4 reduces the nitrile group, CN, to a primary amine, CH2NH2. The OH from the cyanohydrin is not reduced by Lyl4 under normal conditions. Secondary alcohols are stable to Lyl4. So after Lyl4, we have benzene fused to cyclopentane ring with C1 bearing OH and CH2NH2. This gives a compound with a primary amine tethered one carbon away from C1 of the indene skeleton and a hydroxyl at C1. The molecule now has an aminomethyl group, CH2NH2, and hydroxyl, OH, on the same carbon of the cyclopentane ring fused to benzene, effectively making the chain, pH fused cyclopentane, C1, OH, CH2NH2. And for the final step. This is a diazotization condition. Nano 2H plus converts a primary amine to a diazonium ion. The primary amine CH2NH2 becomes CH2N2+. For a primary alkyl diazonium salt, the diazonium is extremely unstable and immediately loses N2 to form a primary carbocation or proceeds via SN1 rearrangement. The carbocation CH2+ is a primary carbocation adjacent to a carbon-bearing ANOH group. This undergoes a 1,2-hydride or 1,2-alkyl shift ring expansion. The carbon-bearing OH, C1 of cyclopentane, migrates to the adjacent carbocation center, resulting in ring expansion of the 5-membered ring to a 6-membered ring. The ring expansion converts the indenone-derived skeleton into a tetraline, tetrahydronaphthalene, skeleton. The migration of the C1 or carbon to the carbocation gives a 6-membered ring with the oxygen as a ketone after loss of H+ from the oxocarbenium ion or rearrangement of the alcohol to ketone. The product of this ring expansion is a 6-membered ring ketone fused to benzene, i.e., a tetralone. The hydroxyl at C1 becomes the carbonyl after the 1,2 shift and ring expansion, and the new carbonyl ends up at the position alpha to the benzene ring, giving one tetralone, option A. This is because the carbon-bearing OH, originally C1 alpha to benzene, migrates, placing the carbonyl alpha to benzene in the new 6-membered ring. Why other options fail? B. To tetralone would require the carbonyl to be beta to benzene, which is not consistent with the regiochemistry of this ring expansion. C. 1, 2, 3, 4 tetrahydronaphthalene has no carbonyl. We would need the OH to be lost without forming a ketone, which is not the outcome here. D. Naphthalene requires full aromatization, which does not occur under these conditions. Therefore, the correct answer is A. Therefore, the correct answer is option A.